So this is the second Chem 1 lesson over stoichiometry. And this time we're going to expand more. We're not going to just do moles. So before you were able to convert from one substance to another using that mole ratio, and we always started with moles. But based on our mole map, we know we don't always have to start with moles. If we started with grams, we can get to moles, right? So let's review kind of these three relationships. So to get between grams and moles, that's where you find the molar mass. So remember that means add up all the masses off the periodic table. That's how many grams there are in 1 mole of whatever that compound is. I can't put a number there because everything weighs different. Then we have between volume and moles. I know 1 mole of any gas at STP is 22.4 liters, so that's enabled us to convert to moles. And last, our particles. 1 mole equals 6.02 times 10 to the 23rd of either atoms or molecules. Now, honestly, in real life, chemists don't very often deal in particles since it ends up being such a large number. You'll find more dealing with volume and grams because those are a little bit more reasonable numbers to be dealing with. So we're able to convert between moles of one substance to another. If we're given grams, the first thing you have to do is to convert it to moles. So the mole map can end up looking a little bit different here. Now we've got a double mole map. So let's say we have one substance, maybe it's substance A, and we have a substance B. If we're going to convert from one to the other, the only thing we can do is we can go from moles to moles, and that's using your mole ratio. Remember, that's your coefficients of your balanced chemical equation. It's the only way you can convert from one to the other. So if, let's say, for example, you were given grams of one thing, and you're asked to find maybe volume of another. Well, there's no arrow that goes directly from one to the other. What you're going to have to do is take grams to moles using its molar mass. Then, once you have moles, you can use your coefficients in your balanced equation for your mole ratio, and then using 22.4 liters, get it back up to volume. So this is going to be multiple steps, but the idea is still the same. We're just taking mole calculations and stoichiometry and putting them together. So for first example, let's see, we are given sulfuric acid reacting with 30 grams of sodium chloride. How many grams of sodium sulfate are produced? So maybe it's time to write out the roadmap. So we're given 30 grams of sodium chloride, and we're asked for how many grams of sodium sulfate are produced. So question mark grams. So this is just like yesterday, but we don't have moles. We've got grams. We are going to need a balanced chemical equation. So let's see, I probably want to put a 2 there to balance out my sodiums, and a 2 in front of my HCl to get it balanced out. So we have our ratio. It's a 1 to 2 to 2 to 1. Now we've identified what we're starting with, what we're trying to find. Now let's think about how this looks on the mole map. So our double mole map, we're starting out with our first substance. We've got sodium chloride, and we know that we have 30 grams of it, and we're asked to find grams of sodium sulfate. So the first thing we have to do is use our molar mass of sodium chloride to get to moles, then use that mole ratio, right? We know that that ratio is a 2 to 1 ratio based on our balanced equation. Then we're going to have to use the molar mass of sodium sulfate to get to grams. So we're going to start with our given. So we're starting out with 30.0 grams of sodium chloride. And I know we're going to have to cancel that out, so I'm going to put that down here on the bottom. And we said, oh, first we have to get to moles. So this is a molar mass of sodium chloride, so you need to add together 1 sodium and 1 chlorine. You're going to get 58.44 grams. So now we've canceled out our grams of sodium chloride and we have moles. Got to keep going. So now we can change our substance. This is where we're going to use that mole ratio. So that means I'm going to take moles of sodium chloride and put it on the bottom. Got to cancel that guy out. And we were trying to get to moles of sodium sulfate. So I'm going to put that up top. Notice I'm writing the substance every time. Our ratio is going to be 2 sodium chlorides, I'm looking at my balanced equation, to 1 sodium sulfate, and that's my mole ratio. Now that we've gotten to the correct substance, right, we've crossed over to the new substance, now it's just a matter of using the molar mass of sodium sulfate. So now I'm going to have to put moles of sodium sulfate on the bottom, got to cancel that out. Then I have to find the molar mass of sodium sulfate. So that means add up 2 sodiums, a sulfur, and 4 oxygens. You're going to get 142.04 grams of Na2SO4. So let's double check that we've canceled out everything we need to. So moles of NaCl have canceled out, moles of sodium sulfate have canceled out. We're left with grams, which is what we're asked to find. So now it's just a matter of multiply across the top, the bottom, and divide, and you're going to get 36.5 grams of Na2SO4. Now it's very important that you include what substance it is because we started out with grams. We have to specify grams of which thing. Our second example, we're given an equation, but it's not balanced. And let's see, we're told find what volume of oxygen is used. So underneath oxygen, I'm going to write question mark volume. So that would be liters. When 85 liters of ammonia reacts. So this problem, we're actually given 2 numbers that are both reactants. But the beauty of stoichiometry is it's all still the same. We can convert from reactant to reactant, product to product, any combination, product to reactant, reactant to product, as long as we have that balanced chemical equation, which we don't have yet. But that's going to serve as our ratio of our reactants and our products. So let's see, to balance this guy, we're going to end up with a 4, a 5, a 4, and a 6. This one got kind of big. And that tells us our ratio. So it's the same idea. We have to start with our given. In this case, it's going to be 85.0 liters of NH3. And we're going to need to convert it this time to liters of oxygen. And we can't convert liters to liters. We're going to have to go through moles. So remember that mole map is only connected through moles. So that means we're going to have to cancel out our liters, 22.4 liters for every 1 mole of NH3. So forget my substance down there at the bottom. So that has canceled out our liters of NH3. We now have moles of NH3, but we do need to get to a new substance, so we're going to have to cancel that out. So I'm going to put moles of NH3 down here at the bottom, convert to the substance we're looking for, which is moles of oxygen. So for every 4 moles of ammonia, I have 5 moles of oxygen. So remember, that is our mole ratio, 4 to 5. Those guys both go down here. Once we've done that, we now have canceled all our moles of ammonia, and we have the right substance. We have oxygen, but we don't have the right unit. We're asked for liters. So extend that line. Got to cancel out my moles of oxygen. Got to get 2 liters. 1 mole is 22.4 liters of oxygen. Now I've canceled it out. So moles of oxygen, we're left with liters of oxygen, which is what we were asked to find. Multiply the top, multiply the bottom, and don't forget your sig figs. Go back to the problem. We should round that answer to 3 sig figs. You're going to get 106 liters of oxygen. Okay, our next example is a mixed problem. So in this question, we're asked how many liters of nitrogen gas are needed. So underneath nitrogen, I'm going to write question mark liters. And we're given 15.9 grams of aluminum nitride. So underneath that, I'm going to write my 15.9 grams. So it's mixed because we're starting with grams. We've got to go to liters, but the beauty of this is the process is all the same. We just need to make sure we have a balanced chemical equation. We can put a 1 there. It kind of seems empty. We can put a 1. So start with our given. So we're going to start off with 15.9 grams of aluminum nitride, ALN. And I know I need to cancel that out, so I'm going to go ahead and put that down here on the bottom. If you remember, first thing we're going to do, if we have to change substance, we have to get to moles. So we're going to need to find the molar mass of ALN, so that just means we need to add up 1 aluminum and 1 nitrogen, and you're going to get 40.99 when you do that. So that's going to cancel out our grams of aluminum. We now have moles of aluminum, and since we have moles, we can now change our substance. So I got to put moles of aluminum nitride down here on the bottom, 2 moles of of nitrogen, N2. So let's check our mole ratio here. For every 1 mole of N2, I get 2 moles of aluminum nitride. So there's my mole ratio. And that means I've canceled out my aluminum nitride, so we can cancel that guy out. And we've got the right substance, nitrogen, but we just need to get it to the right unit, which we were asked for liters. So I'm going to have to cancel out my N2. 1 mole of any gas at STP, which we can assume we are at STP, is 22.4 liters. So now that we've done that, we've canceled all our moles of nitrogen. We're left with liters of nitrogen, which is what we're asked to find. You multiply across the top and the bottom and then divide. Rounding that answer to 3 sig figs, we're going to get 4.34 liters of nitrogen. And we've got one more problem. What mass of oxygen would be needed to react 45.8 liters of hydrogen in the reaction below? So in this question, we're asked to find mass of oxygen. So mass would be grams, so question mark grams. If we're given 45.8 liters of hydrogen. So I've got my roadmap out, definitely not balanced. So let's see, 2 and 2. Got our balanced ratio here. So we're going to start with our given, 45.8 liters of hydrogen. So I got to cancel out my liters of hydrogen. If we got to change our substance, we have to get it to moles. So we can use our 22.4. That's going to cancel out our liters of hydrogen and leave us with moles of hydrogen. So we're to moles, we can now use our mole ratio. So cancel out my moles of hydrogen. Got to get it to, let's check, we got to get it to moles of oxygen. So let's check the ratio here. I got 2 hydrogens for every, there's no number here, remember that means there's a 1. 1, so there's my mole ratio. Changed our substance, which means we've canceled out our moles of hydrogen. We now have moles of oxygen. We're almost there. But we don't want moles, we wanted grams. So that means for every 1 mole of oxygen, we need to find the molar mass of that. Don't forget it's 2 oxygens, so we have to double it. So we're going to get 32 grams of oxygen. When we do that, moles of oxygen cancel out, multiply across the top and bottom, and then divide. And we're going to need to be sure to round that answer to 3 sig figs again. So we're going to get 32.7 grams of oxygen. So we've now expanded our stoichiometry, not going moles to moles, but we can go any combination. So we can go grams or liters to either grams or liters of a different substance, but we can also go to moles. None of these examples did that, but if this last question had just asked for moles of oxygen, we could have actually skipped that last step and finished at moles. So there's actually a lot of different options for these guys, but the big thing is having a balanced equation, realizing that's a mole ratio, so you have to take your given, convert it to moles, use that ratio, and then convert to whatever you're asked to find.